Astonishing discovery. NASA study solves two mysteries about wobbling Earth. Earth does not always spin on an axis running through its poles, they say. This is a NASA article. Grace. NASA study solves two mysteries about wobbling Earth. Earth does not always spin on an axis running through its poles. Instead, it wobbles irregularly over time, drifting towards North America throughout most of the 20th century. As we see in the green arrow on the globe, that direction has changed drastically due to changes in water mass on the Earth. Water has to do with in what direction the Earth's axis rotates at. Now that's a first for me, but let's read the article and see how this happens. Before about 2000, Earth's spin axis was drifting towards Canada. Green arrow, left globe. JPL scientists calculate the effect of changes in water mass in different regions, that's center globe, in pulling the direction of drift eastward and speeding the rate. Speeding the rate? This is astonishing. Using satellite data on how water moves around the Earth, NASA scientists have solved two mysteries about wobbles in the planet's rotation. One new and one more than a century old. The research may help improve our knowledge of past and future climate. Although a desktop globe always spins smoothly around the axis running through its north and south poles, a real planet does not do this. A real planet, our Earth, wobbles, they say. Earth's spin axis drifts slowly around the poles. The farthest away it has wobbled since observations began is 37 feet or 12 meters. These wobbles don't affect our daily life, but they must be taken into account to get accurate results from GPS, Earth observing satellites, and observatories on the ground. In a paper published in Science Advances, this is an article dated, by the way, April 8, 2016, but since most of us don't bother to read what NASA posts, this is new to me, so I guess it's going to be new to a lot of people listening to this, unless you're, of course, a NASA astronaut or some kind of a scientist that has to do with all this. So, Earth's spin axis drifts slowly around the poles. The farthest away it has wobbled since observations began is 37 feet. These wobbles don't affect our daily life, but they must be taken into account to get accurate results from GPS, Earth observing satellites, and observatories on the ground. In a paper published today in Science Advances, Surendra Adhikari and Eric Evans of NASA's Jet Propulsion Laboratory, Pasadena, California, researched how the movement of water around the world contributes to Earth's rotational wobbles. Earlier studies have pinpointed many connections between processes on Earth's surface or interior and our planet's wandering ways. For example, Earth's mantle is still readjusting to the loss of ice on North America after the last ice age, and the reduced mass beneath that continent pulls the spin axis towards Canada at a rate of a few inches each year. But some motions are still puzzling. A sharp turn to the east. Around the year 2000, Earth's spin axis took an abrupt turn towards the east and is now drifting almost twice as fast as before at a rate of almost 7 inches or 17 centimeters a year. It's no longer moving towards Hudson Bay in Canada, but instead towards the British Isles, said Adhikari. That's a massive swing. Adhikari and Evans set out to explain this unexpected change. Scientists have suggested that the loss of mass from Greenland and the Antarctica's rapidly melting ice sheet could be causing the eastward drift of the spin axis. The JPL scientists assessed this idea using observations from the NASA German Aerospace Center Gravity Recovery and Climate Experiment, or GRACE for short, the GRACE satellites, which provide a monthly record of changes in mass around Earth. Those changes are largely caused by movements of water through everyday processes such as accumulating snowpack and groundwater depletion. They calculate how much mass was involved in water cycling between Earth's land area and its oceans from 2003 to 2015, and the extent to which the mass loses and gains pulled and pushes on the spin axis. Adhikari and Ivan's calculations showed that the changes in Greenland alone do not generate gigantic amount of energy needed to pull the spin axis as far as it has shifted. In the southern hemisphere, ice mass loss from West Antarctica is pulling, and ice mass gain in East Antarctica is pushing Earth's spin axis in the same direction that Greenland is pulling it from the north, but the combined effects is still not enough to explain the speed up and new direction. Something east of Greenland has to be exerting an additional pull. The researchers found the answer in Eurasia. Adhikari said, "The bulk of the answer is a deficit of water in Eurasia, the Indian subcontinent and the Caspian Sea area." The deficit of water. The finding was a surprise. This region has lost water mass due to depletion of aquifers and drought, but the loss is nowhere near as great as a change in the ice sheets. So why did the smaller loss have such a strong effect? The researchers say it's because the spin axis is very sensitive to changes occurring around 45-degree latitude, both north and south. Adhikari said, "This is well explained by the theory of rotating objects. That's why changes in the Indian subcontinent, for example, are so important." New insight on an old wobble. In the process of solving this recent mystery, the researchers unexpectedly came up with a promising new solution to a very old problem as well. One particular wobble in Earth's rotation has perplexed scientists since observations began in 1899. Every 6 to 14 years, the spin axis wobbles about 20 to 60 inches. That's 0.5 to 1.5 meters. 60 inches is about 2 yards. Either east or west of its 2 yards is about 6 feet. Either east or west of its general direction of drift. Quote, "Despite tremendous theoretical and modeling efforts, no plausible mechanism has been put forward that could explain this enigmatic oscillation," unquote, Adhikari said. Lining up a graph of the east-west wobble during the period when GRACE data were available against a graph of changes in continental water storage for the same period, the JPL scientists spotted a startling similarity between the two. Changes in polar ice appear to have no relationship to the wobble, only changes in water on land. Dry years in Eurasia, for example, corresponded to eastward swings, while wet years corresponded to westward swings. When the researchers input the GRACE observations on changes in land water mass from April 2002 to March 2015 into classic physics equations that predict pole positions, they found that the results matched the observed east-west wobble very closely. Co-author Ivan said, "This is much more than a simple correlation. We have isolated the cause." The discovery raises the possibility that a 115-year record of east-west wobbles in Earth's spin axis may in fact be a remarkably good record of changes in land water storage. That could tell us something about past climate, whether the intensity of drought or wetness has amplified over time and in which locations, said Adhikari. Okay, I'm going to have to remind myself at the end of this video to talk about one of the reasons that people built pyramids in antiquity. All right, so this is what Adhikari says. It could tell us something about past climate, whether the intensity of drought or wetness has amplified over time, and in which locations. Quote, historical records of polar motion are both globally comprehensive in their sensitivity and extraordinarily accurate, said Evans, and he went on to say, our study shows that this legacy data set can be used to leverage vital information about changes in continental water storage and ice sheets over time. End quote. GRACE is a joint NASA mission with the German Aerospace Center DLR and the German Research Center for Geosciences JFZ in partnership with the University of Texas at Austin. NASA uses the vantage point of space to increase our understanding of our home planet, improve lives, and safeguarding our future. All right, now I'm going to have to remind people from what let me just briefly explain. It was known that in ancient Greece, where they had many ancient pyramids, whether you like it or not, I mean, that's the way it was. They say that the first pyramids were built in Egypt and Thebes, that the ancient Greeks from Thebes, just about an hour's ride north of Athens by car, were the ones that went to build to the ancient pyramids in Thebes of Egypt, and that they were Greeks. For example, they had a lot of names, Greek location names that were used in ancient Egypt. For example, Suez was the inversion of Zeus, or Said, Port Said. Said is the inversion of Dias, okay, which is one of the Greek mythological gods. Now, of ancient Greece, and things like that. Now, they used to build pyramids on top of mountains or in other locations that were high elevation. Why? Because they wanted to create a pressure difference so that they would have rain on land. Of course, the pyramids were built on land, and they would have rainfall. Besides the fact that this rain was used for pure drinking water for the villages around the mountain, a huge amount of water, by the way, every day, it also was a reason to replenish the land with water so that they wouldn't have droughts. And also, there were also scientists who say that they built pyramids in order to control earthquakes. In other words, the pyramids were somehow interacting with the electromagnetic forces of the earth to lessen the earthquakes in the areas. And as we know, Greece is a very seismic area because it's between the European, the African, and the Asian continental plates, tectonic plates. So that's what I wanted to say, that the ancient Greeks had pyramids, one of them being, for example, in the Peloponnese in Taygetos, built on top of a mountain, and they would, other ones around here in Athens, you can see them. I mean, I have to go around with a picture, taking pictures for you. That's something else that I have to remind myself to do. Take a little ride and do my own type of an image and videos of what I see when I drive around Athens. All these mountains have pyramids on, and there are still things not growing on those pyramids because they're rubbles of stone. For some reason they should be covered up, but they're not. I guess from the plenty of forest fires that we've had recently. So that's what I wanted to say. They used to build pyramids in order to have rainfall, to replenish the earth with water, besides the fact that the water would somehow stabilize the area, and the electromagnetic forces would also be stabilized in order to lessen earthquakes. The rainfall, of course, was clean water, rainwater, clean water for the people of the villages to have. So I'll leave a link below for this. This is on the NASA site. NASA study solves 2 mysteries about wobbling Earth.